Hi, this is Ms. White. Welcome to video 1 of our solutions unit. Please have a periodic table and formula chart in front of you as you watch. This video will cover precipitation reactions and net ionic equations. In a double replacement reaction between two aqueous solutions, we can yield an insoluble solid product called a precipitate. So these are precipitation reactions. In this example, we have aqueous potassium iodide. So in there we have iodide ions and potassium ions mixed with lead-2 nitrate. So in our second beaker, we have lead-2 ions and nitrate ions. And when these are mixed, we form solid lead-2 iodide as a precipitate. And then we also have potassium ions and nitrate ions still dissolved in the solution. When no precipitate or molecule forms in a double replacement reaction, there is actually no reaction taking place. So when sodium chloride and potassium nitrate are mixed in this beaker, the resulting dissolved ions actually stay dissolved in the solution because the two products are also soluble. So we have our potassium, chloride, sodium, and nitrate ions all still dissolved in the solution. Double replacement reactions also take place when an acid reacts with a base to form a salt, which is also an ionic compound, and water. So when hydrochloric acid reacts with sodium hydroxide, we form water as a molecule with soluble sodium chloride over here. Because water is formed as a molecule, there is a reaction taking place here. When a compound made of ions dissolves in water, the ions separate from one another, and this separation is called dissociation. For example, we have the dissociation of sodium chloride and calcium chloride in water, and there are the equations. Note that the equation is balanced for charge as well as for the number of atoms. So assuming 100% dissociation, if I put solid sodium chloride in water, 1 mole of sodium chloride will give me 1 mole of sodium ions and 1 mole of chloride ions for a total of 2 moles of ions. 1 mole of calcium chloride will yield 1 mole of calcium ions and 2 moles of chloride ions for a total of 3 moles of ions. For cobalt-3 sulfate, we will yield 2 moles of cobalt-3 plus ions, 3 moles of sulfate ions, for a total of 5 moles of ions. If you don't remember how to figure out the charge on your multivalent cations, you need to please review your nomenclature rules. So far in chemistry, we've been writing molecular equations as if each substance were a molecule. So what are the steps to writing a net ionic equation? Step 1, we write the regular balanced molecular equation with all the physical states. The complete ionic equation turns each substance that is dissociated in the solution into an ion. Step 2 is to write that complete ionic equation. So we will identify which compounds dissociate, and it's those that are soluble. Lead-2 nitrate is soluble, so it will dissociate into 1 mole of lead-2 plus and 2 moles of nitrate ions because I have a 2 here. Potassium iodide is also aqueous, so it will dissociate into 2 moles of potassium ions and 2 moles of iodide ions because I have a coefficient of 2 here. Lead-2 iodide is solid, so it is insoluble, and I rewrite it just like it is because it will not dissociate. Potassium nitrate is also aqueous, so it will dissociate, and we will form 2 moles of potassium ions and 2 moles of nitrate ions because I have a coefficient of 2 here. And this is the complete ionic equation. The last step is to actually write the final net ionic equation, and this ignores any ions that are not involved in the formation of the precipitate or the molecule. So we have to remove those ions. These ions are called spectator ions, and they do not take part in the chemical reaction. They are present in the solution before and after the reaction. So let's see which are the spectator ions. The lead ions are on the reactant side, but on the product side, they are part of the precipitate, so we don't cross them out. The nitrate ions are on the reactant side and on the product side, so they cancel each other out. Potassium ions on the reactant side and on the product side, so they cancel each other out. The iodide ions are on my reactant side, but on the product side, again, they are part of the precipitate, so they do not cancel out. So then we rewrite the equation, removing all the spectator ions. So we end up with Pb2 plus 2I minus gives me my lead 2 iodide solid precipitate. And this is your net ionic equation. Let's practice. We have sodium hydroxide reacting with copper 2 chloride. So we write the molecular equation. We have NaOH aqueous reacting with copper 2 chloride. So Cu2. This will produce sodium chloride. Consulting my solubility rules, this is aqueous, and the 2 hydroxide, so CuOH2, and this is insoluble, so I put the solid here. I have to balance the equation, so I need a 2 here and a 2 here. And step 2 is to write the complete ionic equation. So let's see which ones dissociate. Sodium hydroxide is aqueous, and I have a coefficient of 2. So 2 moles of sodium ions and 2 moles of hydroxide ions. Then I have aqueous copper 2 chloride. So I have 1 mole of copper 2 ions and 2 moles, because of the subscript of 2 moles of chloride ions. Then I do my products. I have 2 moles of sodium ions and 2 moles of chloride ions, because sodium chloride is aqueous and will dissociate. But my copper hydroxide is a solid, so I rewrite it as my solid precipitate. I have to cross out the spectator ions. So I have sodium and sodium, 2 on each side, so they cancel out. Hydroxide is on the reactant side, but on my product side, it is part of the precipitate. Copper also is on the reactant side, but on my product side, it is also part of the precipitate, so it doesn't cancel. The chloride ions are on both sides, so they cancel out. And now I can write my final net ionic equation. I will have CuOH minus plus Cu2 plus will give me CuOH solid. So an example with an acid reacting with a base. If I have potassium hydroxide, so KOH aqueous, reacting with sulfuric acid, so H2SO4 aqueous, that will produce potassium sulfate, H2SO4, and water. Potassium sulfate is soluble, so that's aqueous, and water is my molecule that forms, remember, so there is a reaction. I balance it. I need a 2 over here and a 2 in front of water. Now I write my complete ionic equation. So potassium hydroxide will dissociate, so it will be 2K plus 2OH minus. Sulfuric acid also dissociates, so we have 2H plus SO4, 2 minus. Potassium sulfate is soluble, so it will dissociate. So we have again 2K plus SO4, 2 minus. And then we have our water molecule. as H2O liquid. Now we cross out the spectator ions. So we have 2 potassiums and 2 potassiums. We have sulfate and sulfate. So now we can rewrite that we have 2OH minus plus 2H plus will give us 2H2O, and that's our liquid. Can reduce to OH minus plus H plus will give me H2O liquid. And last one, we are reacting lithium sulfate, so Li2SO4 plus, and magnesium bromide, so MgBr2 plus, and that will produce lithium bromide, LiBr, and magnesium sulfate. I have to balance it. I need a 2 over here, and it's balanced. Now, if I look at my 2 products, this is soluble aqueous, and this is also soluble. So we have aqueous. So we have 2 soluble products, and there is actually no reaction. So I can stop here. This concludes Solutions Video 1. You should have taken high quality notes, rewatch the video as needed, and come to class with your questions.